Okay, so number 10, it gives you the volume of the cone, 1/3 pi r squared h. And then for part A, it just says find the volume when h equals 5. So that should be pretty easy. Volume equals 1/3 pi r squared h. So what is the volume when h equals 5? Any ideas? We know h is 5, but what else do we need? Do we know how to find r? Okay, so it's the proportional thing, right? So we could write this as a two-dimensional drawing. So this length, this total length is the what? Is what value? That's 10. That's the height of the cone. And then what's this length? That's 5 because that's the radius of the cone. But this is our water level. And so this level is changing over time, and therefore the radius is changing over time. So I'm going to call this R and this H. So what's the relationship between those? True, but give me the 10 over H equals 5 over R. And then we can cross multiply, so you say 10R equals 5H. And we'll reduce that and say 2R equals H. True. Now remember, I say don't plug anything in until after you take the derivative. But this problem had nothing to do with derivative, right? So I'm just going to plug in the H that it gives me. It said when H is 5, so it's going to be 2R equals 5. So R equals, yeah, you could. I'm going to leave it as 5 halves. So plug it in here. So volume when H equals 5 is 1/3 pi times 25 over 4 times 5, which is 125 over 12 pi. And what's the units on this? Centimeters cubed. So that's the answer to part A. So it was like 10 point something, is that right? Okay. But it wasn't a calculator problem, so. Did you do that in your head? Oh boy. Okay, don't do that. I mean, it's just taking more time. All right. Part B, it says find the rate of change of the volume. So what are we looking for? We're looking for V prime. That's the question. Well, we're going to use the volume formula again, but we're going to take the derivative in respect to time. So R is a what? R is a function, and H is a function. So what's V prime? 2 over 3 pi R times R prime times H plus H prime times 1/3 pi R squared. And so we just plug in things that we know. So 2/3 pi. Well, maybe we don't know R. I don't know. Do we know R? If we're talking about when H is 5, then R was 5 halves. Do we know R prime? True. We don't know R prime yet. We'll get to that. What's H? 5. Plus, now what's H prime? Yeah. In the problem it said water is evaporating, so that H is changing. So that means H prime is -3/10. And it's negative because the amount of water is decreasing. So it'll be plus -3/10 times 1/3 pi times 5 over 2 squared. So the big question here is, what's R prime, right? So that's where this equation comes in handy. So that doesn't give me R prime, but I can take the derivative now. So that's something else now. So what's that going to be? 2R prime equals H prime. And since I know H prime is -3/10, I can plug that in. So 2R prime equals -3/10. Divide by 2, so R prime equals -3 over 20. And then we'll simplify that. So V prime equals, yeah. I don't want to cross all this out, but the 3's reduce. I guess I will. The 3's reduce. The 2's reduce. Okay, these 3's over here reduce. I'm going to leave it like that for now. So what do we get here? 25 over 20 pi? Actually negative. And what do we get over here? minus 25 over 40, yeah, 40 pi. Because we have to square the 2 also. And then we could reduce this maybe. Actually, let's just do this. Let's get a common denominator right now. So negative 50 over 40 pi minus 25 over 40 pi, which is negative 75 over 40 pi. And then reduce that. So negative 15 over 8 pi. And so our units on this, that's okay. Pi, what's the units? Centimeters cubed per hour. So the volume is decreasing. And that makes sense if H is decreasing because R would be decreasing also. So that's part B. That's where I screwed up on the video and I couldn't post it because I got the wrong answer somehow. Now part C, can I get rid of this? You guys all good with that? Part C actually relates to part B, but I'm going to keep that up here just for now. Okay, so part C, it tells us to show that the rate of change of the volume is directly proportional to the exposed surface area. That's a lot of big words. Show that the rate of change of the volume. So what's the rate of change of the volume expressed as? So we're trying to show that V prime is equal to, it says that, so that it is directly proportional. What's directly proportional mean? Or the other way around, right? So we're looking for when the rate of the volume is directly proportional to the surface area. So that means we can take the surface area, whatever it is, and multiply it by some constant. This is our goal, is to show that V prime is equal to a constant times whatever the surface area is. You guys okay with that? Now, what kind of shape is the surface area? You kind of think of it as a cone, but if it's exposed to the air, then this part of the cone is not being exposed to the air. If it was, then it would just fall. There would be nothing there, right? The cone is what's holding the water to where it's at, right? So is this part of it exposed? No, it's just the top part. So then the surface area, how would we express that? The surface area is what kind of shape? A circle, so that would be pi r squared. So we've got to show this by showing this relationship. Now we already figured out what V prime was. What was V prime?
1/3 pi r.
That's true, but go back to the original function. It was 2/3 pi r times r prime times h plus h prime times 1/3 pi r squared, right? Yeah. Okay. So our goal is to make this look like this. Well, we don't know. Remember, the radius is changing over time, right? It's getting smaller, and the height is getting smaller. Is r prime changing? No. Well, look at what it says. It says the height is changing at a constant rate. So that means h prime is a constant. Well, if h prime is a constant, then r prime is a constant, right? So these values, r prime and h prime, are constant values. So I'm going to plug those values in because I know what they are. So 2/3 pi r times, what's r prime? -3/20 times h is changing, so I don't want to plug that in. H prime was -3/10, and then times 1/3 pi r squared. And we'll simplify this a little bit. Can't do too much with it. The 3's reduce, the 2 reduces, so what do you get? -1/10 pi rh minus 1/10 pi r squared. What is in this equation that I do not want? I'm trying to get it in terms of s, which is pi r squared. K is a constant. Is h a constant?
Yes. Oh, wait, not
No.
that.
So I've got to get rid of h. What could I do with it? Yeah. So what is h equal to? Yeah. So negative 1/10 pi r times h is 2 r's. Minus 1/10 pi r squared. Simplify that some more. So it's going to be negative, well, I'm going to do this so I have a common denominator. Negative 2/10 pi r squared minus 1/10 pi r squared. What do you get? Pi r squared. You guys okay with that? Kind of a mess, but that's okay. It simplifies easily. So v prime equals negative 3 over 10. What was pi r squared? S. So therefore, v prime is equal to some constant times the surface area.
So the constant of the functionality is -3 over 10.
Yep. Constant is equal to negative 3 over 10. That's it.